Hello. Several of the students had actually asked to have the exam 2 review slides posted, so I went ahead and we're going to do that now. So this is going to be the free answer portion of the exam. So you're going to see each one of these, an example of each one of these on the exam. Now the multiple choice questions, those are going to be fundamental things, and so for that you're going to need to look over the review slides. So figure we go through these one by one. Excuse me. Okay, so you're going to have naming the compounds. Now I am going to do the where you have to take the name and draw the structure, but most people do that pretty well. So the first one here, I went ahead and actually drew these out. Right. So the first thing you got to do is make sure that the right. So you have your ring here, and you have your individual chains coming off of here. You have to make sure that the chain isn't longer than the ring. If the ring is, if you have a chain longer than the ring, the chain wins. But for right here, right, we have a 6-membered ring here, right, and then we have a 1, a 1, a 1, and a 3-membered chain. So like that. So here the ring wins, right? So like that. So we have a 1, 2, 3, 4, 5, 6. You just do the ring, right? So like that. So we see 6, right? So right here, let me draw this in black. It's a little easier to see. C6, right? Right. So this would be hex. You know, the base name would be hexane, but since it's a ring, right, we're going to do cyclohexane. Okay. So then we have our side chains like this. One, that. Whoop. Actually, this is 2. I'm sorry. Don't confuse you. That one and this one. Okay. So right there, so we have right, this is 3 long, right? So this is propyl. This one's 1 long, right? It's methyl. This one's also 1 long, so this is also methyl. Okay. So the thing to do, right? So for every one of these, right, you're gonna want to start with a 1, right? Well, we can sort of cheat here because they both start with this, so the numbers would be the same. Okay. So let's assume that, right? So this is 1. You go towards the nearest neighbor, so 1, 2, 3, 4, 5, 6, right? So it'd be 1, 2, 2, right? 2, right? The other option is to make this one 1. You go towards the nearest neighbor, right? So to make this one 1, 2, 3, 4, 5, 6. Okay, so you go towards the nearest neighbor 1. So this would be 2. This also comes off at 1. Now you should also probably do 1 here. Right, but it would just be, right, 1, 1, 2, right, because it's the same one. So you come in here, you add them up. So this is 5, this is 4, this is also 4, but really we don't need to worry about that because it's the same in here. Right, so this is the lower, when you add them up, it's the lowest number, so these are the numbers you're going to put. Right, so then you say, okay, which comes first, methyl or propyl? Right, methyl comes first alphabetically. Right, so here we go. So, right, 2, right? So even though they're coming off the same one, you got to tell me where those are. So it's dimethyl, right? Don't forget, if there's a di here, I need 2 numbers here. Right? 2, 2-dimethyl, 1 propyl, cyclohexane. Right? So I got a cyclohexane, right? I got a I'm sorry. 1, 1-dipropyl. 1, 1-dimethyl, 2 propyl. Sorry, so about that. So 1, 1-dimethyl, 2 propyl, cyclohexane. Right. So I got a cyclohexane. Right. I got 2 methyl groups coming off of carbon 1. Right. 1, 2, and the propyl group coming off of carbon 2. Right. It's a 1, 2, 3 carbon piece. Right. This doesn't count. Right. On your side chain, that's part of the ring. It's these carbons here that you're interested in. Okay, so let's try the next one. All right, so here we go. All right, so we have a 3 carbon piece and another, and 2 more 1 carbon pieces, right? So and then we have, right? So then we also have our ring here, right? So it's C5, right? So 1, 2, 3, 4, 5, right? So it'd be pentane, right? But since it's a ring, so that's the base, right? So since it's a ring, we're going to make it into a cyclopentane. Okay, so then our side chains, right? So we have this group, that group, and that group, right? So we have a methyl, methyl, right? And then this one here, right? So it's 3 carbons long, right? So it's a propyl group, right? But it's not connected at carbon 1, right? So, right, it's 1, 2, 3 long, right? So 1, 2, 3, right? But instead of being connected at 1 like this one was, right? So this one up here, right? 1, 2, 3. So this would actually, you could say this would be a 1 propyl group, but here, since it's connected to it's connected to the main chain through carbon 2, we call this a 2 propyl group. You can also call it an isopropyl group, but I prefer the 2 propyl. So okay, so we need to do the names, right? So we need to start. What if it's 1 is here? What if 1 is here? And what if 1 is there? Right. So here we go. Right. So if we say 1 is here, we go towards the nearest neighbor, right? Which would be here. 2, 3, 4, 5. Right. So you would say 1, 2, 3, 4. Okay. Next up would be, okay, well, what if we said this was number 1, right? So then we go towards the nearest neighbor, 1, 2, 3, 4, 5, right? So that would be, let's see, this is 1, that's 2, and that's also 4, right? Okay, so what if this was 1, right? Well, it doesn't really matter nearest neighbor, so let's just go clockwise, right? 1, 2, 3, 4, 5. Okay, so now this one is 1, and this would be, this one's 3, that one's 4. Okay, so let's add them up. So that's 7, 7, 8. Okay, so we get rid of this one. Now here, so you say, okay, which one it is? You can say, well, you know, so usually, right, when there's a tie, right, you go with the number, whatever number 1 is, the lowest alphabetically gets the number 1. However, with these two things, even though there's a tie, they would actually give the same name, right? 1, 2 dimethyl, 2, 4, 2 propyl, right? So it doesn't really matter. In this case, it doesn't because it's not. But again, if you have a tie, the number 1, the first alphabetically is the thing that gets the 1. Okay, so here we go, right? So methyl comes from 4 propyl, right? Even with the isopropyl, you're just concerned about the propyl. Okay, so you have 2 of them, so it's 1, 2 dimethyl. Right? On the 4, right? At the 4 position, we have this group. We have a 2 propyl. Right? So you could say, right? So you could also put, I like parentheses, 1, 2 dimethyl, right? So this is where it's attached. This is what's attached to it, right? So this is where it's attached. This is what's attached to it. Okay, so at carbon 4, right, we have a 2 propyl group attached. Okay, cyclopentane. Okay, so it's like up here. Once I finally got the number right. Okay, yeah. Okay, so indicate if it's a chiral carbon. Okay, so what are we looking for to make a chiral carbon? Right, we need 4 different things hanging off of that carbon. Right, so here we go. So it's going to get drawn as a skeletal structure, right? And I need you guys to get used to those, right? So I'm interested in that carbon there. Okay, so here we go. So so there's 3 bonds shown, right? So what's missing, right, is a hydrogen. So don't forget about the hydrogen, right? So this is a CH3, right? Sometimes it's easier to just go ahead and just draw what's on here. Right, so it's a CH, right, because there's a chlorine coming out, CH3, CH2, CH2, CH3, CH3. Okay, so what are the 4? Do we have 4 things hanging off here? Well, we have a hydrogen, we have a methyl, okay? This side, right, you can look, say, hey, it's a CH3, right, what's directly attached, and here it's a CH2, right, so that means this side and this side are different, right, so we have 1, 2, 3, 4 different things off of here, so it's chiral, right, so if there's a tie, right, you would normally go 1 carbon out and see if this side is the same as that side, right? But here, they're different, right? CH versus CH2, they have to be different. So we have 4 different things hanging off of it. So that's pretty straightforward. Okay, so here, right? Okay, here I'll go ahead and draw this in CH, CH2, CH2, right? There's an H, right? Because there's only 3 bonds. Right here, let me draw that out. H. CH2, CH. Okay, so we're interested in that carbon there, right? So again, it has a CH, an H, a CH3, a CH, and a CH2. So that means this side and this side are different, right? So 1, 2, 3, 4, right? So this is chiral. Yeah, so not too bad. Now what if we just take this CH3 group and move it there, right? So here we go. Like that. Okay, so remember there's an H coming off of here, right? Because there's only 3 bonds shown, right? So by the way, we're interested in that, right? We're interested in that carbon, right? So there's a hydrogen coming off of here that's not seen, right? That doesn't need to be drawn. Okay, so here we go. So this is CH2, CH2. That's a CH, CH2, CH, right? Okay, so here we go. So we have a CH3 and an H, right? So those are obviously different. Now, what you do here is you go CH2, CH2, right? That's the same, right? So we don't. It's not that it's right. So we're looking at the whole side, right? So what we need to do is then go 1 carbon farther out, right? So CH with an OH on it, CH with an OH on it. Well, that we don't know. And then you come back here to the CH2. If you get to the end of your chain and you haven't found a difference, that means that this side is the same as that side, right? So this side is the same as that side, okay? So you only really have 1, 2, 3 different things on here, so this is not chiral. Okay, at this spot, at that spot there. Okay, so like that. This side of the chain, from this carbon, that side is the same as that side. So there's really only 3 distinct things hanging off it. It's not chiral. Okay, cis and trans, right? Okay, so what's cis, right? That means that both groups have to be going up or both going down, right? So for trans, right, you have to have 1 up and 1 down, okay? It doesn't matter about equatorial, axial, equatorial, that sort of stuff. Cis and trans, those are 2 different things, right? Cis and trans and axial and equatorial are different things, right? Cis is always up, up, or down, down. Trans is 1 up, 1 down, okay? So here we go. So this is, right, so this is trying to be relatively flat, right? So here are your OHs, right? This one's going up, this one's going up, right? So when it's coming, right? So they're both pointed up, right? So this is cis. Okay. Now, it's pretty easy on a cyclopentane. It's a little bit more difficult on a cyclohexane. This one it's easy to you have to determine what's up and what's down. Okay, so each carbon's going to have 1 up and 1 down, right? So we have a carbon here, right? So that's going up, right? So remember for axial, equatorial, right? The bonds point towards the axial, right? So this is pointed up like this, right? So that means the equatorial's out like that. So if this one's pointed up, that means that the equatorial is pointed down, right? Same way with this one, right? The axial's pointed this way, right? So this one, right, this one's pointed up, so that means the equatorial here is pointed down, right? So here we go. So this chlorine is here, that's up. This chlorine is up, right? So it's up, up, okay? So they're both up, so this is cis. Okay, even, yeah, so they're, yeah, so last one here, right? Okay, so OH, right? So remember, for each one we have to have, yeah, so they're both equatorial, so we say, oh, they're cis. No. You have to figure it out. So, right, so here's the bonds point towards the axial, so the axials go, so there's the axial coming up here. So this is up. That means if this one's up, that means this one has to be down. And for this one here, right, at that one, right, where we have the bonds pointed that way, right? The bonds are pointed down, that means axial's down, right? That means this one must be the up. So we have an up and a down, right? So that means this is trans, right? It doesn't matter about axial and equatorial. Cis and trans is up, down. Okay, so if you figure out where the axial is, right, that'll tell you if that one is up, you know, that's up and down. That means the equatorial is the opposite, right? So if this one's pointed, this means that the axial is up. That means equatorial is considered down. In this case, the axial is down here, right? So it's pointed down, so it means the axial is down. So it means the equatorial is up. Okay, we have a down and an up, trans. There you go. Okay, identify R and S. Okay, so so the first thing we have to do, right, so we're interested in that site there, at that chiral center there. Okay, so we have to do our, right, so that's a CH, right, so this is a CH2, right, so we have to look, right, so we're interested in that carbon, look at what's directly attached to it, right, so what's directly attached to that carbon? Well, it's this chlorine, this hydrogen, that carbon, and that carbon. Okay, so what's the heaviest? The chlorine, so that's going to be number 1. What's the next heaviest? Well, it's one of these two carbons, so that's going to be 2 and 3. We don't know which, but we know that the H is going to be 4. Okay, so now we need to figure out which one's 2, which one's 3. So we have a tie. Okay, so we have to see what's bonded to it, right? So we look at the heaviest bonds that are hanging off of that carbon, right? So we have 1, so this one has 3 carbon-carbon bonds, right? And 1 carbon-hydrogen, right? That carbon there, right, has 2 carbon-carbon bonds, right? 1, 2. 2 carbon-hydrogens, right? So you compare what's the heaviest thing, the heaviest set of bonds, right? So that's the carbon-carbon, right? This one has 3, so this is going to be the higher priority. So that's 2, that's 3. Okay, so if you were going to redraw this with just the numbers, right, to avoid all the writing, okay? So, right, so it's going to go that way, like that. So if you're going to do the steering wheel method, right, for doing the steering wheel, the 4 has to be behind, right, so that's where it is. So since it's going clockwise, it would be it would be R. Okay, if you're going to do your thumb method, right, so, right, the thumb should be pointed how the 4 is, and you go 1, your fingers will sweep on your right hand will go 1, and then 2 over here, right, 2 over there, and then 3, like that. 1, 2, 3. Right, so again, it's R. Okay. Okay, so next one. Right. Okay, so here we go. So we have a CH2 here, CH2, 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 CH3, CH3. Okay. Okay, so what do we compare? Right, we have this hydrogen, carbon, 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 right? So, well, the carbon's the heaviest, but we don't know which one. But we know that 4 is going to be, the hydrogen's going to be the lowest. Okay, so what do we do here? Right, so we compare the heaviest things, right, hanging off of there, right? So that has, so this carbon here, right, it has 2 carbon-carbon bonds, right? 1, 2, and 2 carbon hydrogens. Same goes with this one, 2, right? 2 carbon-carbon and 2 carbon hydrogen, right? But this one here, right, it has 1 carbon-carbon bond, but it also has 1 carbon-chlorine bond, right there, and 2 carbon hydrogens, right? So you compare the heaviest thing, right, this one, and this one. Well, this has something heaviest hanging off of it, so this one is going to be number 1, okay? So we established that this side is number 1, so we're done with that one, right? We know that this is 1, this is 4, okay? So then you go 1 carbon out. Okay, so now we're going to compare this one and this one, right? So that one there, right, has 1 carbon-carbon bond and 3 carbon hydrogens. That one there, right, has 2 carbon-carbon and 2 carbon hydrogen, right? So we're comparing the heaviest things that are hanging off of it, right? This has 2 carbon-carbon bonds, right? This only has 1. Right, so this one wins. Okay. So this side will be 2, that'll be 3. Right, so let's redraw this. Okay. Right, so now if you're gonna do the steering wheel method, right, 4 is coming out at you. Okay, so it would be like, right, so it'd be like this. So 4 is coming at you, 1, 2, 3. 3 is going behind, so when we have to switch it, these two switch, and these two switch. Okay, so to flip, just all I did was flip the molecule like this. So from there to there. Okay, so now this one, oops, like that. So these two flip, those two flip. Okay. Okay, so here, right, we're going there, to there, back to there, right? So, right, so this is it's clockwise with 4 going behind. Okay, and so this is R. Okay, so again, if you do the hand method, right? So your fingers will start here. Because your thumb's going to be down into the paper, like just as 4 is pointing. So your finger should sweep 1 to 2 to 3. Your fingertip should swing around. Right? So 1, 2, 3. Okay. So like that. So it's R. Okay. So here we go. Don't forget on those, right? When you're assigning priority, you have to go one step at a time, right? And as soon as you get a difference, you stop. Okay, notice, I forgot to mention that. Notice on this one, right? This was a very short chain, right? These were actually shorter chains, right? Or this one was shorter chains, these were longer chains, right? So even though they're longer, right, we can assign this priority, right? So like that. And so as soon as we see a difference, we stop. It's radiating out from the chiral center. That's where you find your priorities. As soon as you find a difference, you're done. You're done with that side. Okay, we needed to keep going on this one, right, because there was still a tie here, right? So like that. So we needed to go out 1 carbon, okay, until we found this. So even though this is a longer chain than this one, right, this is a 1 carbon chain versus the 3 carbon chain, we found a difference here, and so we stopped. We stopped with this one and could assign it. So be careful with that. Stay disciplined. Okay, so right, so here this is a CH2, right? CH3. Okay, so what are we comparing? We're comparing a hydrogen, a fluorine, a bromine, and a carbon. Right, so what's the heaviest? Well, this is the heaviest. What's the next heaviest? There. there, and there. Okay, so that wasn't so bad. Okay, so 2, 3, 4. Okay, so okay, so it's like this, right? So we have 1, 2. All right, so 1's coming out, 2's going behind, 3's over here, 4's over there. So in order to get if you want to do the steering wheel method, right, you need to move it, right? So the 3 comes up, the 2 goes over here, the 1 goes over here, and the 4 goes behind. Okay? So it goes like this. So again, ended up being R again. Right? So if you're to do the hand method, right, your thumb's gonna be your thumb's gonna be pointed towards the 4, right? And it sweeps just like this. So, oh wait, how did I mess this up? So this is the problem. Because I got these backwards, right? That's what happened. This is the problem with trying to transcribe these again. Right, so 1, 2, I'm sorry. I didn't think these were all R. Because 1, 2, right? So now let me draw this. Again, okay, going over here, right? So so the 1 comes forward, right? The 2 goes to here, 3 stays here, 4 goes back. Right, so now this makes more sense. There we go. Now it's counterclockwise, which is S. Right, so the 4 goes here, 2, 3. So, okay. So you got to be careful when you transcribe these things, obviously, because I screwed up. So there you go. Okay, now pro R, pro S. Okay, so what's happening is, right, so you get these 2 hydrogens, right? So if we make a change to one of those, if we make one of these a special hydrogen, does it become R or does it become S? Okay, so here we go. Right? Because right now, right, it's not actually chiral. Right, so we're interested in that one and that one, right? Because this carbon, right, has 2 hydrogens on it, so it's not gonna, it's not going to be anything, right? So it has 2 things on it, right? So it's no different than regular CH2. It's not chiral. But if we said, okay, right, so the 4 things that are coming off of here, right? So these are going to be 1 and 2, these are going to be 3 and 4. If we're going to say this is a special hydrogen, right, or make it a deuterium or something like that, right? So if we're going to say if that's 3 and that's 4, right, what happens to this molecule? Does it become R or does it become S? Okay, so but we also have to assign the priorities here, right? So this guy, right, so this one here, right, has 1 carbon-carbon bond, right, 3 hydrogens, carbon-hydrogens, right? This one here, right, has 2 carbon-carbon, right, 2 carbon-hydrogens, right? So this one wins, right? So we compare that to that, right? So this becomes 1, that becomes 2. Okay, so if we redraw this, right, I'm going to get it correct this time. 2, 3, 4, and notice that I chose this one here to be the one behind to be 4. Why? Because it allows you to do the steering wheel method directly, right? So right, that because the nice thing is, if one of these is the pro R, that means the other one has to be the pro S. Okay, so just pick one and pick the easiest one for you to do, and then if you get that, obviously get that right, you know exactly what the other one is, right? So this one's going counterclockwise, right? So this was S, so that means that this one here is the pro S, right? So this one here, if we were to make that the special one, that makes this an S, so that means it's pro-S, right? So that means this one has to be the pro-R. You could do that, right? If you flip these two, then flip it around, it becomes clockwise. Okay, but if you know this one, right, make sure you give yourself the easiest one, right? If you're doing, especially if you're doing the steering wheel method, right? So the make this one 4, make this one 3. If it becomes S, that means whatever you made to 3, that's the pro-S. Too bad. There we go. Okay, C and Ray. Okay, so here we go. CH2 and then Cl. Okay, so we have to assign the priorities, right? So this is that's a carbon, and an oxygen, right? So this is going to be 1, right? This one here, right? That right, carbon versus carbon, right? So this has, right? Actually has just one carbon-carbon bond, right? 3 carbon hydrogens. This one here has 1 carbon-carbon, right? But it does have 1 carbon chlorine, right? And 2 carbon hydrogens, right? So that means this because we compare the carbon versus carbon chlorine, right? So this is the 2, 3. Okay, so it would be 3, 2, 1, right? So if we're interested in that face, right? So right, looking down on it, on that face, right? It's going clockwise, so that means if it's going clockwise, it's the ray. Okay, so if you're doing the hand method, right, your thumb is going to point to the face that you're interested in, right? So then your finger sweep again, 1, 2, 3. Right? So it sweeps. Your fingers will sweep 1 to 2 to 3 around. Your fingertips should, and since you're using your right hand, that'll be the ray. If that's the ray, then that has to be the C face. Okay, so ray for rectum, this one for sinister, C for sinister. Okay, so it's the same R and S, right? So this would be as you're looking at it clockwise. If you're looking at it, if you're down on the looking up at down on the floor looking up at the camera, right? That would look counterclockwise to you. Okay, so R and S, ray versus sinister. Or ray versus C. Okay, so there'll be one here. So here's so I gave you just a generic molecule. You need to do the meso form, right, and then indicate the plane of symmetry, right? So go ahead. So I'm going to draw this here, right? So CH3. Okay. So what you need to do is make this so that it has a plane of symmetry in it, right? Because that's the meso, right? Tell me where that is, right? So the easiest way to do that, typically, is to go something like this, right? Make them both coming up at you, right? So if you had a right, so if they're both coming out at you like this, okay, there's a nice plane of symmetry going right here, right? This half is exactly like this half, so there's a nice plane of symmetry going right there, right? So this, one going up, one going down, there's actually no plane of symmetry, right? So if you move this, if you were to move here, right, it would be, this side is not the same as this side, right, because it's not the mirror image, right? Because here the blue is up, here the blue is down. So it's not, there's no plane of symmetry. Okay? So you could either have them both going up or both going down. Doesn't matter. So I'll take either one. Okay. Nucleophile versus electrophile. Okay, so remember nucleophile, right? Right, it's positive loving, right? So that means it has to have negative character. Right? So electrophilic or electrophile, right? It's electron loving. What likes electrons, or what likes negative charges? Positive things that have positive character to it. Okay, so if you're looking at this molecule here, you have to think, right? So if we're interested in that one there, right? So remember, this is a polar bond, right? So what's more electronegative? The oxygen, right? So it'll be negative, positive, and then also between here, there's also a negative charge here, right? So if we're interested in this one in here, right? It doesn't necessarily be a full charge, right? But this one has, right, negative, right? This one has positive character to it. So this is the electrophile. This would be an electrophile. This one has negative character to it, so this would be a nucleophile. Okay. So if we look at this one here, right? Cl. Right, so we're interested in that chlorine there, right? For one thing, it's got lone pairs, right? So that makes it, but also there's a partial positive here because this is a polar bond, right? So chlorine's more electronegative, so that puts a slight negative charge on here, which puts a slight positive charge here, right? Since it has negative character and it has lone pairs, right? So this is going to be the nucleophile. It's going to be loving. It's going to be searching for positive charge, right? So it's a nucleophile. There you go. Okay, energy diagrams. Okay, so what do we know? Right, so we have, it's going to be drawn a little bit more clearly than this, right? So if we have two intermediates, right? So we have A going to B, right? That's an intermediate. Going to C, that's an intermediate. Going to D, right? So this is the reactant. This is the products. These are intermediates. Right? So what else do we know? Okay, so fraction is the second step. So one, right? So 1, 2, 3, right? This is, right? So that's slow. So what does that mean? That means that this one has the highest, activation energy. Overall net activation energy, right? Right, so slower than the first or third steps. The overall reaction is not spontaneous, right? So what does that mean? That means delta G0 is greater than 0, right? So that means that this means that the products are higher than reactants, right? Include the following parts: reactant, intermediates, products, transition states, right? So as you go from A to B, B to C, C to D, there's going to be that hump. There's going to be a little mountain to climb. Each one of those is a transition state. Okay, so here we go. So we're going to draw this, right? Just do your best on the drawing, right? So this is reaction progress. This is energy. Right, so here we go. So we're going to start here, right? So that's reactants, right? And so you're going to have two intermediates here, right? So these are there and there, right? And then the products, right? They have to be above. They have to be, right? So they have to be above the reactants, right? But below the intermediates, right? So you can put them there. Doesn't really matter, but this is all relative, right? So it's going to be there, right? So what else do we know, right? So this here, this gap here is delta G0, right? We're going up, so that means it's not spontaneous. Okay, so, right, so if we're going to make the activation energy, let's do it here, right? What touches this? Here's the first step, here's the second step, here's the third step. This is the one that has to go all the way up. Okay, so that means these guys have to be below. Doesn't really matter, but it's really this middle one here that has to be the highest. Okay, because that's the one that determines the overall rate. Okay, and then transition state. There, there, and there. Okay, so how many of these little arrows do you have? Each one of these arrows is a transition state. Okay, we have an intermediate 1, right? So this would be A, this would be B, this would be C, and this would be D. Okay, so we have this marked, right? So we have this, the intermediates, we have delta G. For the transition states, we have the intermediates. So there we go. Okay, curved arrow mechanisms. Okay, so now you don't have to draw the lone pairs, but it's good to just keep things straight. Okay, you do, however, have to put the formal charges in. Okay, so remember for this, one of the driving forces here is here. I'll go ahead and draw these hydrogens in, just so you can. It's a little bit easier to see. Okay, remember this double bonds, right? Have negative character to them, right? Here we have a polar bond, right? So the more electronegative is the chlorine, so that has a negative, which means this is a partial positive. That's a partial positive, partial negative. Okay, so this negative character here is going to, right? The curved arrow goes from the negative to the positive, right? So here we go. So it's going to take these two electrons here, right, and make a bond with the hydrogen, right? Hydrogen only wants one bond, right? So it's got to get rid of these two electrons here. So what it does is it pushes them onto the chlorine there, right? So you end up with this. So this bond here, right? So so that bond there becomes this bond there. So this double bond here becomes this, chlorine, hydrogen. This becomes the hydrogen. Okay. That leaves this carbon here with only 3 bonds. So it has a formal positive charge, right? And then this chlorine here, right, gets a 4th set of lone pairs, right? So this bond here became that lone pair set here. Okay, so this second bond here became this new carbon-hydrogen bond there. This bond here, these 2 electrons became a lone pair there. Now, oops, did I put them on the wrong spot? I did. Now, how did I know that the hydrogen went there, right? Because it says it there in the product, right? So it actually ended up being, the hydrogen ended up going there, right? Right, so you have to be careful about where I ask you to put things, right? So the positive character is there. So this hydrogen here is that hydrogen there. Okay, it's gonna be a little easier. It's gonna be a little bit easier on the test. Okay, now you have a positive charge thing and right, negative charge things. They're going to be attracted. So it can donate. Doesn't matter which one. Let's say this set of lone pairs here comes in and it's going to say, hey, I can make a bond. I can donate these 2 electrons, and you can have a 4th bond. Okay, so when you do that, right there. So these 2 electrons became those two bonds there. Now everybody's happy. Everybody has their octet filled. Okay. I think that's it. Okay, that's the free answer part of this exam. So keep practicing on this. So again, I'm sorry for the little mistakes here. So I hope they aren't confusing. So good luck.